Cool. All right, why don't we go ahead and get started? I know people are trickling in, but let's go ahead and start. First of all, thank you, everyone, for attending my Turbo Talk session about insecure IP storage networks. My name is Himanshu Dwivedi. I work for At Stake out of our San Francisco office. So here's the agenda for the next 20 minutes. It's a very, very tight agenda, but I do have some bonus material that aren't in your slides, so I will add those to the Black Hat website right after this. If you are looking at a slide deck, it's the very, very last slide deck in your big fat red book, so just in case you're trying to find it. So here's the quick agenda that we'll go through. Basically, what are we talking about here today? We're talking about insecure IP storage network. So what is that? Usually that means network attached storage, also known as NAS. So in our diagram here, on the right side, you have a network attached storage device. Now this could be an EMC device, a NetApp device. Even Microsoft now has its own storage server, storage appliance that you can have installed on your network. But what does it do? Well, basically it offers up storage capacity, whether that's 2 gigs, 2 megs, 2 terabytes, whatever. It's a device on your network to offer up storage to applications, operating systems, what have you. So what's the purpose? Well, applications like Exchange or Oracle or Microsoft SQL Server, your data requirements change on a month basis. Well, instead of adding in new hard drives to your operating systems, you just allocate new storage via your storage device on the fly in a nice, easy way. So you don't have to worry about your storage capacities as much if you have a storage device. Well, how do you talk to these things? How do you communicate with these things over IP? Well, you usually use NFS or CIFS. Now, there are some proprietary protocols you can use, but the two main implementations of NAS devices are NFS and CIFS. And that's really the problem here with storage security in terms of the NAS world. So just like anything else, whether it's an operating system, a router, or switch, by default, storage devices are insecure. Now, there's a lot of things you can do to secure these systems. There's a lot of features that they offer, but again, by default, they don't support them, and by default, they are insecure. So there's nothing new we're talking about here, really, except when we get to the iSCSI section at the end. But when we're talking about NFS, and we're talking about CIFS, we're talking the same implementations of those protocols. CIFS is Common Internet File System, also known as a subset of SMB. NFS, Network File System, obviously in the Unix world, the way we get access to remote data stores. Assumptions. You go into storage networks, you go into clients of ours, and they'll think their EMC storage array is secure. They'll think their NetApp filer is secure. That's great if it is. That's great if they enhance their devices or add some security or even add some encryption. But by default, these things aren't secure, and a lot of people are assuming, oh, let me go secure my Windows operating system. Let me go secure my Solaris operating system. That's great, but if I can get access to your data easier than I can get access to your Windows server, what's the point? So these are two protocols we'll be talking about. So how would you go about in attacking a NAS device? What are the steps? Well, the steps are no different than anything else. In fact, in the Google talk earlier, the gentleman pointed out the attack scenario of a pen tester, pretty much the same idea. But you'll see the results are pretty much, I would say, more significant because you're getting access to data. You know, you're getting access to lots of data, gigs and gigs of data quite easily. So what would you do? First thing you would do is scan the system using Nmap. So if I can, I'm actually going to try to show a demo of this. I know this is probably pretty bad resolution, so I apologize. But before we begin, on the right side here is basically a Unix system, a Linux system with a SSH connection. On the left side are my local drives, CD-ROM drive. You can see I have no network storage here. My antivirus is disabled, by the way. Right here is my Windows shell. So we're going to go ahead and hit play. And I know you can't see this, so I'll walk through it. Basically, we're scanning the system, we're scanning the storage device. What we're going to get back in return are common protocols that we're used to seeing, such as NFS, port 2049 and 4045, SMB, port 445 and 139, and we're going to get RSH, we're going to get Telnet, and if they installed SSH, we're going to get that, and we're definitely going to get HTTP. So we have two attack vectors here. We have the data attack vector for CIFS and NFS, and we have the management attack vector, HTTP, Telnet, RSH. So we have two attack vectors if we are an unauthorized user trying to get access to data. So next thing we'll do under our Windows shell, I'm going to pause it here for, well, actually I won't pause it. Under Windows shell, there's a tool called WInfo written by Arne Winstrom. He wrote this tool to enumerate information from Windows operating systems. Again, this tool won't work completely on a NAS storage device. Because it's implementing CIFS in a default nature, we will be able to enumerate the shares on the NAS device, the shares that we can try to mount to get access to data on the file system. So as this tool is run, you're going to see we won't get a lot of information about the policies, the accounts, the information about the password change policy, but down at the bottom here, we do get the share information. You'll see one share that's common on the Windows world called the IPC $ share, which is in your booklets. And you can see we get some other ones that are new, like Home, Etsy $. These are all customized shares on the NAS device itself. Well, how would you do that if it was talking NFS? Well, use the show mount command. You basically type show mount. Anyone who knows NFS, this is very easily you do. You just type show mount and you'll get all the exports. What's important to know here that everything is exported to everyone by default. By default, there is no controls. So if I pause it here, what it says right here is all machines. All machines have access to those exports by default. That's very bad if this is a Oracle database holding credit card numbers. If it's not, then maybe this is not so bad. But if you're using your storage devices to hold critical information, this is what's happening by default. The next, well, good question. The question is, how do you get show mount on your Windows box? Basically, what I'm using here is Unix services for Windows. But you can do this on a Unix box also. The next tool that I'm going to kind of show is called enum. This is a tool written by BindView. What this does is enumerates admin accounts on the network device itself. So before I was talking about there's two attack vectors, the data attack vectors and the management attack vectors. Well, these three accounts, which you can't see, but it's the administrator account and two dummy accounts, are root level users. On most NAS devices, there's no such thing as a non-root user. Everyone's a root user. So basically, you're 3 accounts away, you're 3 passwords, 3 brute forcing attacks from owning the administrative functions of that NAS device. And just like everything else, if you own the admin functions, you own all the data. So if you own the admin root account of a Solaris system, that's important. But if you own the root level account on a storage device, you own all the data that's sitting on top within that device itself. So pretty bad, but we'll actually get into worse attacks here in just a second. So this is just a screenshot of what we went over. So what we've done now is just enumerated information. We haven't done anything really significant, to be honest. So now what we're going to do is mount that information by using the information that we've enumerated. What we would do is use tools called mount and net use. Mount and net use are nothing that fantastic. You'll see them on most default installations of systems. Let me skip ahead here. Okay, so below here, again, you can't see it. What I'm doing is putting a mount command, and I'm logging on to these NFS exports that I enumerated anonymously. No username, no password, no authentication required. If you look up here, in just a second, as soon as I hit enter on this command, I'm going to have a drive appear automatically, anonymously over the network. So I've now connected to the NAS storage device with no authentication just by enumerating the exports, and I'm going to do the same thing with the net use command and attach to a share. Now on Windows, you can't actually attach to a share that is actually a file system by default anonymously. On a NAS storage device, you can. This is why it's more insecure than most Windows implementations. So you can see here, I'm now browsing. I have read and execute access to everything in that NAS device. So whatever these folders are, whatever these files, I don't have write access. So I can't completely own everything, but I have read access. So again, if it's a database, it's an Exchange server, all that stuff is there for me to read as much as I want. Again, no authentication was required whatsoever by default. And within Windows, like there's that C $ share, I cannot connect to that anonymously and still get access to that volume. On a storage device, I can. Yes, but from Windows to Windows, I can't do that. So that's what these devices, one point why EMC and NetApp and all these vendors do this, because they want to be invisible in the network. They don't want to be an entity. They want to be like, we are your storage, we are your Windows system, we are your Unix system. They want to be invisible. Well, what they've done is open themselves to attacks. Because it's talking IP, and we can access the IP interface, we can attack the device itself instead of going through the operating system. Again, what's the point of attacking the operating system when all the storage is sitting on this device and it actually is more easier to get into? So moving on to the middle of the presentation, the next thing we'll talk about is permissions. So being that we can connect to this device, we can enumerate the shares, we can enumerate the exports, authentication is not required. What would we do next? Well, we would want to set file permissions, right? Well, file permissions become extremely important since access seems to be very easy to get. So in this example, we have a folder called patient information that we want to secure. The username in green here called Himanshu should have access. The username called Dwivedi should have no access. So what we're going to do is show another demo how user permissions with implementations of NFS and CIFS are insecure. So a lot of storage devices only support one or the other. You can have them only support one or the other. But in most implementations, you see them supporting NFS and CIFS for Unix and Windows clients. So what we're going to do is show that. So this is our legitimate user. The user with the blue background can get access to everything. And I know you can't see this, but I'll walk you through it. So in a moment, I'm going to switch to a different user with a black background. I'm going to VNC it to a different user. That's the user we don't want to have anyone have. This user should not have any access. So you can see we're in a different machine. Office is installed on this machine, so you see the icon show up. But basically, we want to protect that directory called patient information. So what would we do? Well, as a Windows user, what we would do is go ahead and put file permissions on it. So we're going to go back to our other machine, right-click, hit Properties, and go ahead and hit the Security tab. We're going to remove the administrator and the everyone accounts. That's why we were able to get anonymous access, because everyone is allowed access. So we're going to remove those, go ahead and put our username, give ourselves full access, hit Apply, hit OK. So great, now we've secured that folder. We feel very comfortable, especially since you don't need any authentication to get access to that. As you can see here, we're denied access. We still have access to other folders within that directory on that NAS device, but we do not have access to that patient information folder. So this is very good so far. But because this entity, this storage device, supports NFS and CIFS, it's vulnerable to the NFS problems with file permissions. This is a very, very, very old attack. But it's still very popular, especially when it comes to storage devices themselves. So what would we do is demo this also. So in this situation, we have that same Dwivedi account on a Unix system. Again, the same account that we do not want them to have access to that folder. And you can see when they try to CD or try to CD into that patient information folder, they're denied. Because you can see the only person who has access to that is the UID of 6161. But what is that UID of 6161? That is the Himanshu account. When that user locked everyone else out except themselves, the NAS device automatically set the UID of 6161 to only have control of that folder. So what we'll do here is basically drop down to root. Again, we own our operating system. We own our Linux machine. What we're going to do is drop down to root, which gives us ourselves a UID of 0. And then we're going to say, hey, NAS device, why don't you go ahead and give us access to everything? Because we're UID 0. We are the God account. God should have access to everything. And you can see here, we get access denied still, which is very good. So this storage device is actually saying, you know what? Even though you have the UID 0, we don't care. UID 0 will not map to UID 0 on our storage device. You are nobody to us still, which is very, very good. But by default, they didn't do that for any other user ID. They only did it for the UID 0, but nothing else. So what I'm going to do next, since that didn't work, is pretty much go to my local Etsy password file and change my UID not to 0, but to 6161. Yes, this is, again, a very, very old attack. So some people will say, as we walk through this attack, well, this is an NFS problem, right? Well, yes and no. It's like, you know, a bank, right? You have your PIN card and you have your PIN code. They get $200 out of an ATM, right? But if you want to go get jewelry out of the vault, you have to have a key. The teller has to have a key. You have to have your bank account number. You have to have more information to go to the entity that has all the money. Well, the entity that has all the data is just as vulnerable as any other NFS machine on the network and any other Windows machine on the network. In my opinion, the entity that has all the data should have more security than the entity that's just an operating system. So you can see here, we've changed our UID to 6161 on our local account. And now what we're going to do, we're still the root user here. What I'm going to do is go ahead and drop down to that new Dwivedi account. Again, that Dwivedi account used to have the UID of 3. It's been changed to 6161. So I'm going to switch user to that account. Log in. So now you can see my Dwivedi account, which used to be 3 at the beginning, is now 6161. We do a directory listing on that same directory, and now it looks like we own all those accounts because it thinks we are the user ID of 6161. So I'm going to go ahead and CD to that patient information folder that I was denied 4 times in a row, and you can see I'm allowed right in quite nicely. So I've just basically broken all the security permissions that CIFS user placed on that directory with common and very old NFS attacks. These attacks still work. Just because it's on an EMC device or a NetApp device doesn't mean it's gone away. It's still there. So going on to our next section. Again, these are screenshots of what we just did. So sniffing. So what's the big deal about sniffing? Well, there is no big deal really. Sniffing is still possible. Now Kerberos, NFS version 4 will stop the attack we just showed because it uses Kerberos. But if you're using Kerberos in an Active Directory domain, you can do basically a denial of service on port 88 and have that NAS device drop down to the lowest common denominator, which will be NTLM. So you can still make it talk NTLM over the network if it thinks the Kerberos service is not available. So you can just sniff those hashes over the network quite easily. You can do the same thing with Kerberos session tickets if you can capture that at the right time. Or you can just sniff RSH and NFS because those are clear text protocols. Why are we using clear text protocols when it comes to storage? When it comes to data and lots of it, I still don't know. Well, here's the reason why clear text protocols are so bad. And this is where the iSCSI part comes into play. iSCSI is more of a storage area network technology, not really a NAS technology. It doesn't use CIFS or NFS, so let's forget that for now for just a moment. iSCSI can use 3 levels of security. It can use authentication using CHAP. The authorization is something called an initiator node name. It's like your DNS name, if you will. It's your initiator node name. And the third thing is encryption. So the only thing required is your initiator node name. Authentication is not required. So your CHAP authentication is not required to access the data. Why authentication is not required to access data puzzles me. You need authorization, but again, authentication is optional. We'll go through that in a second. So what is your initiator node name? Well, that's basically, again, it's like your DNS name, and there's something called a simple name server on these storage networks, on these SANs. That simple name server basically takes your initiator node name and then maps that to all the drives you have access to. So drive 1, 2, 3, and 4 belong to this initiator node name, and that's how it basically identifies you. Kind of like DNS, same idea, but it actually maps access to what you have as far as the iSCSI storage device. So what we're going to do is show our very last demo. And I apologize, these demos aren't very big. That's totally my fault. So what I'm going to do is scan for 2 ports, port 3205 and 3260. Port 325 is the port that the simple name server listens on. So that's why I'm scanning for port 3205, because I want to find my simple name server. I want to find this device. I'm going to scan for port 3260 because that's the port that the iSCSI storage device is listing on. So iSCSI listens on 3260. Port 3205 is that simple name server. So we'll scan for that on my local network, and hopefully I'll be able to get something back. And you can see, obviously, I will. So I get 1, 2, 3, 4 storage devices, 4 iSCSI storage devices, and what I've highlighted there is the IP address of that simple name server. And because the protocol is clear text, I can just bring up my favorite sniffer. In this case, it's Ethereal, and I'm just going to sniff over the network for all communication over 3205. Now, if I can't sniff I can't sniff on a switch because I can do an ARP game and ARP spoofing attacks and have all that communication from that simple name server to the default router come to me first. Or if I'm on a hub, I can just sniff over the network because it's a clear text protocol. So you can see here, we're going to bring up Ethereal. We're going to start sniffing. In just a moment, we see all this data. Well, I know you can't read that, but what we're going to do is bring up a iSCSI session, and that's an initiator node name right there. If you can kind of read that, it basically says a whole bunch of stuff, and then it says Cisco. So this is an initiator node name from someone using the Cisco iSCSI driver. The key thing here is we just captured someone's initiator node name. Now we can spoof that. That's all we need. That's all that's required to spoof and get access to someone else's disk drives. So what we're going to do is capture that. I have a whole log of those, of ones I've captured when I was doing this assessment. So go ahead, and we don't need Ethereal anymore because it's a clear text protocol. We didn't have to do any kind of Uber stuff. I'm going to bring up my iSCSI driver, my Microsoft iSCSI driver, and what I'm going to do is point that at that iSCSI storage device. In this case, I'm using that last one, 1060.192.188. Hit OK. I'm not going to log in yet. Before I hit log in, I'm going to show you guys my local disk management properties. And you're going to see here, I have my local hard drive and I have my CD-ROM drive. This is what I should have because I only have one drive on my system. So everything looks good here. So what I'm going to do now, and all I've done is done a port scan and put that IP address on my iSCSI client driver. going to go ahead and log in. So that's what I just did. Now I'm connected. I'm going to go back to my management interface and look back at those disk drives that I was just looking at. And in a moment, you'll see nothing's changed. Well, why hasn't anything changed? Again, you need that initiator node name. The thing that we sniffed over the network, you need that. So what I'm going to do is conveniently change that in my driver. I can change that to whatever I want. So since I sniffed one, mine is there. It says Microsoft because I'm using a Microsoft driver. I'm going to go ahead and take the one I sniffed that I put in that log file and basically change it. So at this point, I'm just spoofing my initiator node name. Going to go ahead and hit change, re-log in using the iSCSI client driver. Hit log on, hit OK. Again, so far, what have I done here? I've enumerated the iSCSI storage device connected to it. I sniffed the initiator node name over the network in clear text, and I added that as my own node name, so I spoofed that. So in a few moments here, you'll see a change into our local storage. It takes a while because now instead of having one drive and one CD-ROM drive, it has a lot more. And so it takes a while for it to come up. And so you can see here, disk 1, disk 2, disk 3, disk 4, disk 5 are all in my control. I set that to persistent, I reboot, I can do whatever I want with that data. And how did I get access to that data? All I had to do is sniff one port 3205. It's like sniffing DNS. And that's all I had to do to get access to this. Again, there's a solution out there. It's called authentication, but it's not required. Authentication is not required. If it were required, this attack will not work. It definitely will not work. But by default, again, we come back to the beginning. By default, these storage devices, whether it's NAS talking CIFS or NFS, or an iSCSI storage device, or even a SAN, by default, these things are made to work, made to be open. Unfortunately, you can target these things, especially iSCSI, because we're now talking internet protocol and not fiber channel. You can target these things directly instead of targeting the operating system that it's connected to. So, in conclusion, what am I saying here? I'm not saying things are bad. I'm saying by default things are bad. Go ahead and look at your storage devices. Make sure that you do enable these features, whether it's Cisco, Brocade, QLogic, McData, EMC, NetApp. They all have solutions in terms of security. You just have to enable them. A lot of them do a lot of good things, but again, by default, most of them aren't enabled. Some questions, shameless plug there, I apologize for that. Some references to some of the tools I used on the NAS and CIF side, so I want to make sure I reference those people. But I'll open it up for questions if I have time. Yes, I do. No questions? When you configure the NAS device, you can definitely enable it. But if you configure it and use the wizard, or you just configure it to start, the only thing it will require you to do is set up groups, and that's the initiator node name and the disk drives it has access to. But if you're the administrator, you can say, yes, I want to go enable CHAP and require CHAP authentication. Yeah, so the question is, so is there any kind of encryption? No, that's just the authentication. The key thing here is encryption is optional. IPsec is definitely available, but of course for performance reasons, they could not require that. And I actually agree with that. For storage, performance is everything. So you can't necessarily take a hit with IPsec, but if you want to use that encryption, it's available. On on SANs and Fiber Channel, it's not really available, so this is actually something better when you compare Fiber Channel and iSCSI. Question?
Can you do something secure on NFS without?
Yeah, good question. Good question. So the question is, can you do something secure to NFS without v4? Well, for authentication, unfortunately, you can't. With NFS v4, you can enable Kerberos. If you're using v2 and v3, what I would probably do is limit the enumeration possibilities, which you can do. So you can't, everyone won't be able to enumerate the shares or the exports, but you could use, or another thing you could do is try to use like some kind of authentication like LDAP instead of using flat authentication, but you still can subvert that with UID mapping. So you're pretty much handcuffed if you're doing 2 or 3, to my knowledge anyway.
Because v4 isn't available.
No, v4 is supported by all these devices. I know NetApp and EMC do support v4. Yeah, and actually one of the storage vendors I talked to last week They say it's been available in Solaris since '98. I didn't know that was true, but according to them, it's been available for a while.
But it hasn't been standardized.
Yeah.
Like a year ago.
Yeah, and that's a good point. Standardization between all these vendors is a big reason why security doesn't really work well, because everyone's trying to do what their own thing, and they're not really using these standards up until, a couple years ago. Very good comment. So the question is, how bad is the performance hit if you have crypto hardware? There's a couple of crypto vendors out there. To be honest, I've never done any testing on that, so I'm not qualified to say. I work closely with a lot of these crypto hardware. They say you can get up to, you could get very low performance hits. Of course, I don't know if that's the marketing thing or if that's the true thing, but companies like Decru, Neoscale, Cache and Chase all have encryption appliances that you can put to secure the data. So who cares if I can get access to that iSCSI target? All that data is encrypted. If that's true and the performance is not hit, I think that's a good recommendation. But again, that's not something I've actually tested. Oh. Yes. Oh, so the question is that implementing NFS over SSH. Well, while I love SSH, you're going to have a performance hit. You can tunnel it, so you can basically tunnel NFS ports, 2049, 449, 445, all these dynamic ports for NFS, and tunnel that through an SSH connection. You can do that, but performance-wise, you will have some penalties there. Any other questions, comments? So good question. The compatibility for open source clients on iSCSI, or? Okay, so the question is, what's the compatibility for open source clients on iSCSI? Honestly, I don't know. The iSCSI stuff only got in here in the last second because I completed it on Wednesday. So the only two clients I've used is Microsoft, Cisco, and a Linux client, but they're all vendor-based clients. There's nothing open source that I've seen out there. Okay, so there is something on SourceForge that IBM produced on for open source clients. That's good to know. Thank you. Intel has one.
I think it's actually Intel.
Oh, okay. So it's the Intel one on SourceForge.
Or maybe
Any other questions? All right. Thank you.